Hi guys, Frankenstein here. Today I want us to take a look at the fixed bias circuit, fixed BJT transistor circuit, and how to deduce the input and output equations. So first of all, we need to be able to draw the fixed bias circuit, right? So what you do first is that you'll draw the VCC section. So this section will be the VCC on top. And then here you must have always two resistors, and also here you must have two resistors. Very important. And then there you have your transistors inserted. So that will be the collector section. That will be the emitter section. Right. And then there will be the referencing section, which is referencing to the ground. That's GND. So that's the GND section. Let me try and write that a bit clear. GND. Yeah. So what we need to do is understand the nodes. That this node here, it is the base section. So here it's the base. And this node here, it is the collector section. So C, collector. And this node here, it is the base section. Sorry, not base. Sorry. The emitter. Very important. Now, when you're doing this, you're helping yourself. And then let's take other nodes. So you get this node. And also that node. And that node there, referencing to it. Now, we need to label the resistors now. How are you going to do that? So, because this resistor is on the collector section, we can label it as RC, resistor C. So, RC. Because this resistor here is on the base section, we can call it RB, resistor of the base, right? Now, let's deduce the input formula. So, where do you find the input formula? The input formula, simply you find it on the left side. So left is where you get your input. Your input section. Sorry. Your right. That's where you get your output. Right? Very important. Once you know that, you basically can solve any transistor circuit. Always like that. And then let's try and deduce that input equation first. So we're going to be looking at the left side. So this, let me just keep the left there, and then right. And then yeah, let's write the input equation. So this is the input equation, right? So what I want us to do is we're gonna take the voltage between nodes, né? But now let me just remove this node because it's basically the same thing. There. So I want us to reference to certain nodes, which they're gonna be helping us to see clearly. Let me just use a brighter one. Yeah, so between this section there's a voltage, and between this point to that point there is a voltage. So I can say that the voltage here is a voltage between the base and the emitter. So it's VBE, right? And then the voltage from here to there, it is the voltage of the resistor. So I can say it's a VRB, right? So meaning that for my equation, I can simply say it's gonna be, but remember that this voltage here is being supplied by a VCC. So if I add the two voltages, I'm gonna be getting my VCC. Okay, sorry guys for the pause, just fixing something quick. Now, these two voltages, I said that they will add up to VCC, because if you understand is that this section to this section, it's connected to a battery. So from here to here, you're going to have VCC. So these two sections here are basically a voltage divider in a way, right? So meaning that I can say that VCC is equivalent to VRB plus VBE. Is that fine? Now after that, what I'll do is that we'll expand this one, because what I want you to know is that always the input equation, the subject of the formula for the input equation is IB. So you must make sure that IB is within the equation. So we can go back to Ohm's law. Ohm's law says that VAR, so V is equal to IR. Therefore, VRB is equal to IB RB, right? So I can write that to be VCC is equivalent to IB RB plus VBE, right? Therefore, I can continue to say that IB is equivalent to VCC minus VBE divided by RB. There you go. So that is the input equation. So this equation is the input equation, right? So let's try and introduce the output equation. We're going to do the same thing for this equation. Let's do the same thing. So I'm going to erase this just to create space for ourselves. Now remember I said that the output equation will be on the right hand side, right? So let's write it. So the output equation, so meaning that if you check properly, I'll go and highlight my nodes, which is important. The voltage VCC will be distributed among this section, and it will be distributed among that section, right? So meaning that VCC is equivalent to VRC, right, plus VCE, right? Because remember, from this node to that node is C to E, because E here is the same one, right? So that is the input equation. But always you must know that the output equation, the subject of the formula must be VCE. Therefore I can make VCE subject of the formula. Therefore it's going to be VCE is equal to VCC minus VRC, right? So that's the output equation which you must be able to deduce in terms of maybe being told to deduce it, right? And from that you can always expand that section there, which is not really important here. You can expand when you're trying to simplify. You can simplify this to VCE is equivalent to VCC minus IC and RC, because it's basically just VAR. So yeah, that's how you usually deduce those two expressions, which are very important. Yeah, but any guys, we'll meet in the next one. Cheers, enjoy.